Hello. Today we'll be talking about properties of magma. In general, magma is made up of only 8 elements: oxygen, silicon, aluminum, iron, calcium, sodium, magnesium, and potassium. Oxygen makes up slightly less than half of the magma. Silicon makes up slightly more than a quarter of the magma, and the remaining elements make up the final quarter. To help me remember these elements in order of importance, I've made a mnemonic. It's at the bottom of the screen. On Sunday, all is calm, so make plans. Magma contains 3 components: melts, solids, and volatiles. The melt is made of ions from minerals that have liquefied. The solids are made of crystallized minerals floating in the liquid melt. The volatiles are the gaseous component and can be water vapor, carbon dioxide, sulfur, or chlorine that have cooled and dissolved in the magma. There are 2 types of melts: decompression melting and flux melting. Decompression melting takes place within the earth when a body of rock is held at approximately the same temperature, but the pressure is reduced. This happens because the rock is being moved toward the surface, either at a mantle plume or a hot spot, or the upwelling part of a mantle convection cell. The process of flux melting occurs if a rock is close to its melting point and some water is added to the rock. The melting temperature is reduced, the partial melting starts. Virtually all of the igneous rocks we see on Earth are derived from magmas that form from partial melting of existing rock. Bowen's reaction series describes the temperature at which minerals crystallize when cooled or melt when they heat. There are 2 branches to Bowen's reaction series: the continuous branch and which is the evolution from being calcium rich to more sodium rich, or the discontinuous branch, which describes formation of the mafic minerals olivine, pyroxene, and biotite mica. The composition of the original magma is critical to magma crystallization because it determines how far the reaction process can continue before the silica is used up. The amount of silicon dioxide present determines whether the magma is mafic, intermediate, or felsic. Felsic magmas contain 65 to 75% silicon oxide. Intermediate magmas contain 55 to 65% of silicon dioxide. And mafic magmas contain 45 to 55% silicon dioxide. Pictured here are examples of mafic, intermediate, and felsic rocks. The word mafic is derived from using the Ma for magnesium and the Fic for the Latin word for iron. Common mafic rocks include basalt and gabbro. Basalt cools quickly at the surface and is extrusive. Gabbro cools slowly underground, is therefore intrusive. Mafic rocks are usually dark in color. The word felsic is derived from using Fel for feldspar and Sic for the high percentage of silica. The typical felsic rocks include granite and rhyolite. They are usually light in color. Felsic magmas tend to be cooler than mafic magmas when crystallization begins. Intermediate magmas fall between felsic and mafic. Typical intermediate rocks include dianite and andesite. These are produced during the conversion from mafic to felsic or from hotter to cooler. Thank you.